Okay, this is lesson 1-1A, rational numbers. Before we get into the lesson, I do want to start off by reviewing some of the vocabulary words that are in this section. The first of which was rational numbers, which is the title of the lesson. And basically, a rational number is any number that can be written as a fraction. Okay, any number that can be written as a fraction is an example of a rational number. So some examples of rational numbers would be -7. Because -7 can be written as -7/1. Excuse me. Another example would be 2 2/3. Because we can change this to an improper fraction, which would be 8/3. And I can show you how to do that later if you don't remember. Another example would be 9%, because 9% can be written as 9/100. So any number that can be written as a fraction is considered a rational number. The next term that we have was terminating decimals. And basically, a terminating decimal is any decimal that has an ending point, which the word terminate, that's where we get terminating from. It means to stop. So a terminating decimal is any decimal with a stopping point or an ending. Okay, so for instance, decimals that have endings could be like 0.625. It stops after the 5, so it's a terminating decimal. 3.23, terminating decimal. Another example could be 111.2, terminating decimal. It doesn't matter how many numbers are in front of the decimal, as long as after the decimal it comes to an end somewhere. The decimal just doesn't, the numbers just don't keep going on and on and on forever. Okay, which brings us to our next term, which is a repeating decimal. And a repeating decimal is just what it sounds like. It's a decimal that has a repeating pattern in it. So for instance, a repeating decimals, let's write down the definition first. Decimals that have a repeating pattern of digits. So for instance, the decimal 0.3333, and it just keeps going on and on. It never stops. It's called a repeating decimal. What number is repeating? The 3 over and over and over again. So we would write this 0.3 with a little bar over it. That bar is telling you that this 3 is actually repeating over and over and over again. But for the sake of not having to write a million 3s, you just write a 3 with a bar over it. Another example could be 0.45 repeating, which means 0.454545, and so on. The 4-5 continues to repeat over and over and over again. So you can see that a repeating decimal can also have a whole number in front. let's do 2.4 repeating. And that would be 2.4444, on and on and on. So it's just the decimal portion, the numbers that come after the decimal that actually repeat, that makes it a repeating decimal. Okay.